And the program is more or less divided in three parts. First of all, I will tell something about well, the challenging circumstances recycling has to deal with today. Then Jeroen Jansen of Radboud University will make a deeper dive in the characterization and analytics on recycled content. And I will come back to you and give some explanation how these aspects could be recorded in a digital product passport and why we should do that. And in the end, I will come back to the some background on TI Coast and the community of practice circular economy, where we are that we have built together with the team. So allow me to go back to the next slide. So this webinar is organized under the umbrella of TI Coast, and within TI Coast, we founded the community of practice circular economy with various companies and knowledge institutes. And one could say our main quest is how to get to a standardized physical chemical characterization of recycled content, to create a uniform nomenclature for recycled content, because there is no uniform language in this field at this very moment, and how we could record that in a digital product passport. We have a core team of Erik van Sprang also in this meeting, Harry Philips of Envalior, and also board member of Coast, and who is still trying to get in this meeting. Guido Smets, who is in the meeting, van Fontis, Michiel van der Stelt of Hogeschool Utrecht, Jasmijn Ruigrok of In Holland, and Jeroen Jansen van Radboud Universiteit. And well, and people are still very welcome to join our community of practice. I will come back to this phenomenon later on. Then a little bit on ourselves. So my name is Frans Bekkers. I'm from CERMA. CERMA is a company working on the establishment of a circular economy. So we concentrate on building circular strategies, products, and concepts. We try to make that work in operations. So we organize reverse logistics, recycling, refurbishment solutions, and try to find the next use applications for recovered materials. And we already in 2015 we started the development of a digital product passport, C-passport, that's in the market. Our main focus is in B2B environment customers, and sometimes also for government bodies. And well, now I go into the content of the day, because important enough, as Europe we have a challenge. Geopolitical situation is very harsh at the very moment. On one hand, because of the situation in the US, but more focused in our area is on the developments in Europe, leading to a situation where on one hand there will be a re-industrialization in Europe. A lot of investment will take place, and we don't know the exact amount yet, but over 1 billion over 1,000 billion of euros will be invested in European industry, both in the civil industry and defense industry, where it can be divided anyhow. And on the other hand, we see that on sustainability, we have the Omnibus Directive, let's say of about a month ago, and leading to a simplification and reduction of, amongst others, the CSRD directives. And well, maybe that's a blessing in disguise, where bureaucracy has been diminished, and maybe the economic rationale of the sustainability and especially circularity is going to win from the compliance rationale, and companies become more and more economic driven instead of compliance driven, because we think preserving the quality and value of materials should be the highest priority in in the European economy at the very moment. Because if we really want to invest this amount of money in a European industry, then we will have a material availability problem. And that's what circularity is about. How can we organize enough feedstock supply for the European industry, knowing that on an average we are importing between 60 and 80% of all the materials to Europe, and depending on the kind of the material group that is concerned. So, and even from that perspective, it makes sense to increase our recycled volume. Having said so, we know all about the R-ladder. Jeroen Jansen is from Nijmegen, and also Ad Lansing, the former member of Parliament in the Dutch politics, who started with the ladder van Lansing, one of the predecessors of the current R-ladder. And there are people saying, well, you shouldn't recycle at all, so you should stay at the top of the ladder. But well, we all know that's in practice that doesn't work in a lot of cases. And for that reason, we should build up more and more recycling capacities to make sure we have our feedstock available. Well, how does that work? When we look at the European plastics industry, we are producing about 50 million tons of plastics in Europe annually, where globally we are even above 350 million tons. And predictions say it will go to 500 million tons on a global scale. And we know that approximately 5 million tons of plastics are being recycled in Europe at the very moment. One could discuss the quality and the levels, but our question is how can we raise that amount, and for example go to 5 million or 10 million or 50 million tons annually, at least, to make sure our feedstock is secured. Because one could say plastics are not scarce at the very moment. Well, I can predict if they're not geologically scarce, they could become geopolitical scarce. And also from that perspective, it makes sense to put more effort on recycling. And also remark on that aspect, we are not going to solve the geopolitical problems of today in this webinar. And we know the plastics recycling industry is under a huge pressure at the very moment. When we only look at the Dutch surroundings, we see more than 9 companies going bankrupt in the last 10 months. And also the current politicians are not really, well, recognizing the problem or helping the problems. Last week, the Minister of Environment said, well, companies could be helped with extra loans, but the sector said, well, we already have enough debt in our sector, and loans will not help, but support would really help to bridge possibly a certain period of time, whatever that period may be. Well, having said that, then how could we get from strategy to practice? We have already recycling in place in the current market, and we call that passive recycling. We try to make the best out of it after a product has been used. But the ideal situation, of course, would be that we could grow to active recycling, where design for recycling or design for disassembly is built in the design of a product or even a material. And in the actual industry, we see that's still a very, very small minority of examples where we see that the end of use and the next use of a product is taken into consideration, and that could be improved. So we say, okay, let's grow to such a situation where we have both for the medium term still this passive recycling, and we grow to this active recycling. But then still we need a lot of instruments to make this happen. And I'm not looking at the legislative instrument, but today we're looking at more the technical instruments, both in the recycling industry. Still a lot has to be done in research. Still concepts have to be circular concepts have to be improved, and of course more and more we're getting our tools to support and to foster these the products and also the materials that are connected to it. Well, having said so, if all these aspects would be in place, and a lot of companies are working on this, then we think we're still missing something, and that's the aspects of the preserving the quality and the value of the materials. As I said, we cannot solve the current geopolitical problems, but what we could try and do is to increase the information value of recycled content, and that starts with analytics and the recording of the information of the material. And for that, I would like to introduce Jeroen Jansen of Radboud University, who will make a deeper dive into the analytics of materials. Jeroen, if I can switch over to you, please.
So thank you very much. I will take control. Yes, this was all well rehearsed. So this is basically what in a linear economy being safe, cheap, sustainable looks like. Yeah, this is all revolving around quality. There's quality by design, which is sort of a holy grail, that you don't need to measure any of your products anymore because you've done all the hard work way before. Um, but what it does, yeah, is in fact implicitly it creates something you could call trust in your process, that you're always going to produce the thing that is, well, the product that is going to be bought in the market. Yeah. Well, of course, there in the I'm slightly behind in my slides, with the CSRD. There was the promise that not just quality and money could be generated going forward, but that as an outcome, also sustainability is going to be a major driver for no, the process industry and industry as a whole. But what's going to happen there actually is slightly different than how we go about creating quality. Yeah. Because that was going to end up or is going to end up in an end report, a CSRD, an ESR report, where you are going to report the performance of your company at the end of the year. Yeah, so the best that's can happen, of course, is that you're going to see in December that in March you should have done something completely differently, and you'll make sure that in the future you will not make that mistake again. Yeah. If you would go about the same way with something like quality, you wouldn't have a company anymore in quite soon. So my philosophy is that at least circular economy, but sustainability as a whole should be done forward. Hey, we should work towards sustainability, and also sustainability is so important in a lot of economic performance metrics in the company that it's going to make money in the end. I have several examples that show this already. This is actually to show where I'm coming from, and I can promise you, around these years, I was in my first year and of chemistry studies. So this was done way before me, but this is developed in my lab, the first conveyor belt for plastics. The big 5 plastics are here, and how you can generate data. This was the first online sensor on a conveyor belt to detect and identify these plastics and to sort them accordingly in the correct streams. As you can see here, if you read well, this is done for construction material in the image, but this has been done for a lot of product groups. But basically what we do in the department is that we turn good analytical data into value creating decision power. Yeah, and let's see. Yes, because now we go on. Because this has been growing, of course. We're talking about 30 years ago now that this was built up, but not just technology. Like this is the hyperspectral imaging device FX17 of Specim. Well, it's the FX10, but we have both. Those are being much more advanced technologically, so we can obtain much more advanced data, much more detailed data, but also plastics have grown. Yeah, because 30 years ago you would buy packaging which was a thick layer of monomaterial, and nowadays packaging is much thinner but constructed from multiple layers of different material that each have their own function. The big issue is if you start to recycle it, yeah, uh, a multi-layer packaging like we have here on top, which is a multi-layer of, as Martier has developed, a tomology uh, um, um, algorithm that we can look into the plastic to discover the multiple layers. This is a multi-layer of PP and PE. Yeah, so this single piece of plastic doesn't belong in um, either the PP stream or the PE stream. Yeah, because it's a mixture of both. There has to be done some sort of a pre-processing. If you don't care about this and put it with either the PP or the PE stream, it's going to pollute those streams. And by itself, because now we can do tomography, we can really look into the material itself. Yeah, we can start to look into the 26% of the flexible packaging uh, material that is going to come across by weight as multi-layer packages. So we're going to be able to create new streams of these multi-layer packaging, and we might be able to recycle them separately. Yeah, because they are going to be an increasing part of the plastics waste that we want to recycle. The same approach, yeah, doesn't only work for multi-layer packaging, but what we can do here, for example, is very quickly with the same algorithm identify PET bottles with a PE cap on top. Yeah, the white part here means that they overlap, so the cap is on the bottle, and that means that we can start to separate these bottles in separate streams so that we can unscrew the caps and separate them independently. So what we can do is we can build the basis here with new artificial intelligence to generate new waste streams of value. Yeah, but we can also identify new operations that could turn existing waste into new value. This is example number one. Example number two, and so this is the Spectrum camera that sets you back in total perhaps 50 or 60,000 euros if you want to buy it, and then you need to put it on your conveyor belt, and you need to train a lot of data to make a good sorting model. Yeah, analytics is also revolving in different ways, or developing in different ways. And one important one for us is the handheld spectrophotometer. As you can see in the bottom right, is the Trinamics. This is not according to scale. It is a portable device. It is slightly, it's got this size. It's a large torch. And together with Eki, the a regional plastic producing company, we were able to use this handheld technology so that can be carried around by the operators in the company to separate cross-linked from non-cross-linked waste material that they generate. And they need to separate those because they are being collected and recycled separately. If you mix them up, you get poorer material. So sorting these out into these separate buckets of cross-linked and non-cross-linked material actually generates money here. And that is, as I said, your circularity is going to turn into economic profit in the end. A third example that I want to show you here is we take it outside the realm of plastics. We're going to look at animal feed because this is the environmental impact, the life cycle analysis of animal feed. And that is being separated into three main contributions. There's the agricultural practice. So this is future agricultural land in Brazil on the right. On the bottom, you see the production that may be regionally regulated, and there's transport from A to B, from agriculture to production. So those are very major contributions. The thing is, you can obtain this information, these coefficients, to calculate the environmental impact from a database. They're very well regulated and very well protocoled on how to calculate this. The only thing that we need to know is where are we and where is the ingredient coming from. And that is, aside from quality, which we can analyze quite well for different different outcomes for different ingredients in the animal feed production. Yeah, we can understand the nutrition in real time. As you can see here on the top left, you see here the critical chemical bonds for certain outcomes for animal feed ingredients. But you can turn this around because this fingerprint on the top left that is already being collected for quality control, you can also use, and now I have some advanced animation, we can turn it around. Yeah, because it also contains the information, if you know what material you look at, where is the material coming from? So you can put it on the map without a paper trail. So that is very important. It is an intrinsic property of your material that you can identify whether it's from Great Britain or from Ukraine. So that means that integrating this information into your LCA calculation, you understand sustainability in real time, environmental impact, yeah, without having to rely on a paper trail. So it's an intrinsic material property. That is, of course, an extremely strong step ahead. And you can use that into mixing the ingredients into an animal feed. Yeah. So this is a dashboard we created where we are plotting the environmental impact of the ingredients that we have on board. And we can plot it against the price of a mixture that we generate. And then you can see in blue, this is the original original realization if you don't use any quality control data. If you integrate your life cycle assessment with your quality control, you get to the bottom left. So anyway, you're cheaper, as you can see. You're always cheaper, at least for these two comparisons, and you're much greener. And you can pick from this red range of animal feed recipes with sufficient nutritional quality. You can pick the cheapest if you want to, let's say, be produce for a price as an endpoint. You can also be as green as you want. Then you can be choose the greenest recipe with the optimal LCA profile, but you can also balance the two. Yeah, and if you balance those two, what you see here, if you compare the colors, the red one is the new recipe and the blue one is the old recipe. You can see that the potential in environmental gain that you get, which is in the median 40%, goes at a marginal reduction or actually a marginal increase in the cost price, in the economic price. So that means that actually on the whole, sustainability makes money. Yeah, and what is very important is that the circularity, as Frans already indicated, protects your supply chain because this is a restricted number of ingredients, but because you do quality control and environmental impact analysis at the same time, your circular ingredients fit very well into this representation. You can basically integrate them as new potential ingredients and start calculating with them for profit in the environment and in the economy. So this is my contribution. And now I give the floor back to Frans.
Thank you very much, Jeroen. Uh, Well, having said so, on one hand, we have the geopolitical challenges and the current and actual challenges in the. I'll take it back to the plastics recycling industry.
Mhm.
Let's zoom on this aspect for this moment. And we said, okay, we could be able to improve the information value of recycled content, for which Jeroen gave us some examples and also made a step outside the plastics recycling to other material groups, because this could work for other material groups as well. And then we say, okay, and then what could we do then to make sure that this information also will land at and receivers, or I would say application manufacturers. So I would like to invite you to scan this QR code, and maybe Natalie, Walter, you will recognize this. And if it works, you will get into a digital product passport of a granulate, a polyol granulate, out of the beverage cartons. Well, also the industry has been looking for the last over 20 years to find better recycling solutions for beverage cartons. And there are various initiatives all over the world. And one of the new initiatives is a new factory that's now being built in the Limburg region in the Netherlands, based on a concept of recon polymers, and also in the west of the Brabant region, where the aluminium polyethylene combination, sometimes in a little bit of polypropylene coming out from the beverage carton, is being recycled and being put on a grade for specific applications. Well. And over here, you really see the economic essence of a digital product passport. Maybe some of you know that there's also coming out of the European Green Deal. One of the directives is the ESPR, the Environmental Sustainable Product Regulation. And one of the aspects in this regulation is also the digital product passport. And the first three product categories have to be accompanied by a product passport in 2027. That counts for, let's say, a fair share of the total textile market, electronics and batteries. But we say, well, there's also an economic rationale for a digital product passport, and that's securing a feedstock supply. By adding the information coming out of the characterization of recycled materials, and adding to that a uniform nomenclature, uniform coding or a name to recycled content, because that doesn't exist for the recycling market yet. And we know that all prime materials already have a code, have a name, so the buyer knows what he or she buys and where it can be used. For recycling content, that doesn't work, and it's not there yet. And so now we see that trading has been done batch by batch, and for every batch, the sample has to be tested if it is applicable for a certain application. And what we like to achieve is that the process quality of the recycling industry is also a guarantee for the product quality out of the recycling industry, which is in the prime industry is already there for the last 40 years. So in this digital product passport, we record the material composition of a material product or a semi-fabric. You put in the weights, you put in the composition, you describe the end-of-use solution and next-use applications that are possible with this materials. In this case, also the MSDS of the product of the material is connected to the digital product passport. So also from a, let's say, a data management perspective, already existing phenomena could be combined, and well, having the material composition, the weight, and the end of use and next use solution of the product, you can also, the system automatically calculates then also the product carbon footprint, and also within various scopes, the cradle to gate, cradle to grave, or what we call LCA plus, so taking into account the next use as well. Passport should be dynamic. So if we have additional information, let's say tomorrow, the day after tomorrow, on a product component or a material, it can be added, whether it will be the composition information or a next use application information. And so that means that you have always the last information connected to a specific product. Well, how does it come together then? Huh? So in the analysis and the characterization, we know what kind of material is in a product. What is the percentage of recycled content? Because that's also an issue, for example, in textiles, but also in the upcoming legislation on where more and more recycled content should be used in new products. Are we able to do inline or offline measurements? That's also one of the challenges in this industry. What qualities and what grades can be found. So and for that, which characterizations are relevant to get to these outcomes. We think it's finding a standardized way of characterization of recycled content would really help the industry, together with finding a uniform nomenclature which we are working on in our community of practice within Coast. And having done that, we say, please record that in a digital product passport, so this information is secured, is anchored, and it increases the information value of your recycled material for your buyer, and that at least helps a little bit in being more competitive compared to even in this current challenging market. Yeah. Okay, where could you use this such a DPP, a digital product passport? Well, essentially in all stations in a supply cycle. So in the sourcing stage, production stage, a use stage, it much is used in the reverse logistics and the sorting stage, and then again you have information to put the materials in a new cycle again. And so with that, you can also always start wherever you want in the supply cycle. I mentioned the difference between what we call passive recycling and active recycling. Also, we have examples where initially non-circular products are being recycled, and then a digital product passport is added to this material to at least have extra information for a new round again. So there we see that you can increase the information value, and that this is really interesting. We see examples where the information value could be increased between 10 and 50% of the, let's say, of current values. You have a confirmation of the qualities and the application areas for your customers, and from a, let's say, macro perspective, but also from a business economics perspective, the next use is secured, and you have new feedstock for new products, whether it be the same on other products. Okay, are there any questions until now on what we have discussed? So I look at my colleagues. Are there questions that have not been answered yet?
Yes, Frans, we have one question. Oh no, that's a comment I see by Jeroen himself. I'm sorry.
No, it's a question.
It's a question. Oh, okay.
Yeah, because I see there you're reporting. Yeah, in the report you give the absolute numbers for things like energy and CO2. But what I learned from my colleagues in LCA is that the real essential thing is to have a relative number. So to have a reference point to base these absolute numbers on.
Yeah. We calculate the absolute numbers for CO2, energy, and water. We calculate a relative number for the material savings. And
Yeah.
then it's compared to incineration. And you can imagine if a
Yeah.
product is incinerated end of use, then in the next round you need 100% of new material again, whether it comes
Yeah.
from a recycled source or a virgin source.
Mhm.
And for the other KPIs, we don't do that, but there's also a dashboard connected to the passport, and there you can compare scenarios. So to say,
Okay.
well, sometimes you make what we call worst, and best scenarios. And say,
Yeah.
okay, what would be the case if a product is only built up of virgin material and will be incinerated after use?
Yeah.
Versus a situation, an ideal situation where you have only recycled content as input, and end of use, the product will be recycled or refurbished again. And then what would be the relative improvement on that? So that possibility is there, and indeed, yeah,
Okay. Yeah. Oh,
yeah,
interesting. Yeah.
yeah. If there are no other questions, I switch over to the part on what we do within Coast. We have what we call the Holy Trinity. They say it makes sense to, as already explained, to combine the phenomenon of on analysis on one hand, trying to find together because that's a business and knowledge institutes exercise to be done jointly. Find a uniform nomenclature for recovered materials, and having that recorded in a digital product passport, again, to increase the information value of materials, and to increase the application areas for recycled content, because then with these kind of aspects, you will be able to also to give more comfort and security to your buyers of recovered materials. So if you would like to join that, please join and let us know. So what do we in our community of practice? So on one hand, we look at let's say in-depth content as aspects of materials, so the impurities, and how can we optimize the sorting and washing of materials. How can we connect them to next use applications, as I already explained, but also the safety aspects that play a role. How can you also make sure that you don't need, let's say, specific additives and materials anymore that could be a barrier in the circularity of a material. And of course, as Jeroen also explained, we always approach that from an economic perspective. The circular solution should be competitive to the let's say the virgin solution, where we essentially say we should be able to produce a better material or a better product for the same price as the linear product. And then for that we used analytics as being pivotal for these challenges. So what do we? We organize webinars, workshops, like today. We organize symposia. We have use cases also with companies, but also knowledge institutes. We work together and cooperate in R&D proposals. Well, you can read yourself. So we are in the mid of a network, or on one hand, chemical companies, producing companies, knowledge institutes, and analytics organizations. And we also connected to, let's say, umbrella or platform organizations like CPNL or CPI, DPI. But also for the German listeners, we also connected to Fraunhofer and German universities. So what is our focus for the let's say the medium term? In plastics on one hand, and within plastic soft materials, but also the rigids. We are focusing together with the Saxion Hogeschool also, and Hogeschool Niederrhein at textiles, because also there a lot of challenges to be solved. We look at construction materials, within this community of practice. The coast as a whole also looks at the pharmaceuticals, at water, and etc. But that's with this community of practice. And well, a lot of the technical topics that I already mentioned and June mentioned in our presentations are our, let's say, red thread topics that we are dealing with. Yeah. Well, going forward, have some upcoming events in the next months. And on the 22nd of May, we have an online workshop, and we will all invite you on the topic of the blending requirements. So in Dutch we say the bijmengverplichtingen. And well, for a lot of product categories, there will be obligation to put recycled content in it, or being able to recycle a certain percentage of these products. And I know that politics are very flux at the moment, but well, in the Netherlands for packaging, there will be a blending requirement in 2027. Well, there's still a political discussion going on. If it won't work, won't take place in the Netherlands, then at least on a European level, it should take place in 2030. There are plans to introduce blending requirements for the automotive industry in 2028. Still not, let's say, in stone carved legislation, but these are the plans. And the same counts for, let's say, blending requirements for textiles. And within this online workshop, we are going to say, okay, how could this be approached? How could this work in practice? But also, how could we add analytics and nomenclature and a digital passport to this to find solutions where we could say to lawmakers and policymakers, well, use our concept because that can work in a total market, and also within our community of practice, we can demonstrate that it really works, and trying not to find out something different. Early in June, we will participate in the fair of lab technology, and we give our presence with some presentations, but also some of our student projects will be presented then. On the 19th of June, Veridis, one of the partners, will present its characterization application. After summer, Jeroen will organize a webinar on the theory of sampling, and we also in autumn we will organize a webinar on the recycling of composites, because also there we see a lot of end-of-use material is approaching the market, and the solutions are not there yet. And at the same time, we have a lot of business and student use cases already running. And if you are interested in joining one of these cases, or have your cases of your own, please address it to us, and we'll see how we can connect it to one of the or more of the partners that are in our community of practice within the TI Coast. I think we are almost at the end of our webinar. First of all, thank you for your patience, and our apologies for the fact that maybe these participants cannot hear this. Maybe it didn't work for those organizations that have maybe some more harsh security barriers in their systems. We have to find out what went wrong over there, but we will make sure that all those that have applied, that they will get the connection to the video. Are there still questions to be answered?
I see no further questions, Frans, inside the Q&A. There was one question, but that was deleted somewhere during the meeting, so I can't refer back to that. Okay. But I see two questions popping up just right now.
Yeah, I see a question from Martin Volmer.
Yes.
On packaging, yes. Let's say contaminated materials as a whole. So also in packaging, the labels on packaging, that's also one of the topics we are looking at. So if you have a case on that and you are interested in setting up a project together with partners within the TI Coast, please be welcome because we know that, let's say, recycling of monomaterials that already takes place, are already solutions for that. And we say, okay, the challenges are, of course, in multi-materials or contaminated materials. And that also counts for the packaging with the labels on it. And you also so specifically asked for how does it work on the digital product passport? Well, you can build up a product passport in various components, and you can in the passport you can say, okay, what parts can be really in practice can be recycled, and what parts cannot be recycled yet, whether it be mechanical or chemical. And then it's and those also then you get a what we call a nuanced end of use solution percentages. So still a part is being incinerated or a part is being recycled. Okay, and for the rest, I see a lot of people saying thank you. Yeah. Okay. Then I suggest we close the meeting. Thank you again for your attention, and I hope really to meet you all again in one of our next events. And have a good day.